I'm Brazilian, but I will speak in English because I have to speak to. So I'm here to talk about Linux kernel rootkit. This is my friend Ilya. I bring him from Russia to talk about that shit. And I hope you guys enjoy this talk. So.
Yeah. Is it working? Oh, okay. So hello guys. Nice to visit this place. I really like Brazil. I'm here first time. Yeah, and today we. Yeah, thank you. Today we explain something about Linux kernel rootkits. Tell you something about Linux kernel rootkits. Have anyone of you guys tried to write any rootkit? No? No one. Okay. Because I think that every programmer have to write a cryptographic library and rootkit. Yeah. Okay. So let us start. So yeah, I'm from Russia. My name is Ilya Matveychikov. I'm Linux kernel programmer.
I haven't presented me. So I'm Igor. I know by Forbidden. That's my nickname. Some guys who work with me will know him. We are talking about rootkit programming, but we won't talk about malware and exploitation. You guys, all you know what is a rootkit? Yeah or not? No? A rootkit, this introduction is blah, 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 yeah.
And we are talking about this right now, yeah.
Okay. A rootkit, this is the hacker definition of rootkit. So there's this a toolkit that will be on the root of the system. So why rootkit? Is a kind of software designed to provide continuous privilege. So continuous privilege is go infected forever. That's the main thought about rootkit. So rootkit is a APT that try to infect. The really reason to write a rootkit is infect something. Computer, server, smartphone, all stuff, all technology stuff, infect something. We can classify rootkits, just an overview here, about user mod rootkit. LD preload base is a specific technique to write a user mod rootkit. Kernel mod rootkit, that's we are going to talk about, kernel mode. We are going to talk about LKM based, I will explain later. So firmware-based rootkit, UEFI, is a hardware rootkit called something about bootkit. Hypervisor rootkit is in VM level. So hypervisor is an onion of software between the kernel and the hardware that provides VM. So there's some ways to hook in hypervisor, and there's ways to write rootkit for hypervisor, and hybrid rootkits that is mixed techniques. So why?
Why?
Yeah.
Yeah. Why to write another one kernel-based rootkit? Why not? Yeah. But the main reason is that from inside the kernel you can alter whole system behavior more precisely, more better than, for example, from user mod. And also, it is extremely hard to detect such kind of rootkits from the user space, because if you have properly written rootkit, it's totally invisible for user space. And overall, it's a great challenge. Yeah, if you trying to understand how to make kernel mode programming rootkit, it's a good starting point for doing this. Yeah, and which are the challenges for writing a good kernel mode rootkit? First of all, kernel mode programming requires deep knowledge of how operating system works, how it interacts with hardware, and like this. And if you have some bug in your code, for sure bug will crash the system sooner or later. Yeah, and to write a good rootkit, you have to define a scope of work before starting to do this job, because if you don't know what you want to achieve, you will get nothing. Yeah, and one more thing about Linux kernel rootkits, because programming for Linux kernel, it's kind of art, especially if you want to write a code that can work for all the variations of kernels. And that is one of the challenges, because, for example, I have an example here. You know Red Hat, and they have CentOS free operating system. Yeah, and they have a kernel, let's say 2.6.32, but it's actually not 2.6.32, but it's based on 2.6.32 kernel with some backporting features. So they are developing this kernel maybe, I don't know, about maybe 5 or 7 years. But
yeah, the main difficulty to write rootkits is take the code generic as possible to all kernel versions. So this is the hardest part. So we'll talk about some techniques about rootkit, and we'll talk about some how to take the code more generic. Okay.
Yeah, and there are some constraints if you are in kernel. Because it's not user space, so there are some constraints. And the first constraint is that the kernel has API, and this API it's not so big, and it changes quite often. So it's hard to manage all possible versions of kernel, because API changes from version to version. Also, in general, if you have LKM-based rootkit, LKM stands for Linux kernel module. So if you want to develop this kind of rootkit based on the kernel model, you have to rebuild for each kernel you want to have rootkit. You have to rebuild this rootkit from sources for almost every version of the kernel. So it's impossible to have just only one binary for rootkit to work on every target you want. Yeah, and the one thing more is that this rootkit probably will not survive between kernel update, because if a kernel version changed after the update, this rootkit will not work. Yeah, and also if you are in kernel, you have restricted set of methods of functions you can call. So you cannot do everything that you can do from user mode. Let's try to download file and unzip this file from HTTP from inside the kernel. It's quite complex task.
Yeah. This is some features that a rootkit not have to have, but it's very nice to have these features. Be able to survive a reboot and update kernel. So this feature is very hard to do, but this is the best feature that a rootkit can be, because if you survive the reboot and survive the kernel updates, you can stay persistent. So this is the main feature that a rootkit can have. So be able to change the whole system behavior. Yeah, we will write a software, a malware that will do something, do malicious something, and normally will change the system behavior. This is what we are going to do. So we have to be able to hide files, to hide folders, to hide process, network connections, users, and what you want. The main feature that rootkit that can be is hide something. Just hide. So we are be able to evade against detection, because there's a lot of protections actually in lots of detection ways to get a malware inside the system. So we have to evade these techniques of detection. We have to stay stealth. The rootkit's purpose is staying stealth. So, and we have to be able to provide a payload execution. Actually, a backdoor or a keylogger, whatever. We have to get some payload execution, maybe remotely, maybe not, but inject something inside the kernel stealthy. So, next slide.
Unfortunately, we cannot fit all these topics today. Yeah, but let's continue. Let's start with basic kernel techniques.
Yeah, we start with the basic kernel techniques because we have to start the beginning. So the beginning is rook syscall. Rook syscall. Syscall is a function that provides the communication of user land and kernel land. So if we hook syscalls, hook just put hook. This syscalls, we can change the behavior between user land and kernel land. So in Linux, we have a structure, a list called syscall table, a table, yeah. And when in architecture x86 for 64 bits, we have a instruction of processor that you just do syscall, and this instruction will point to the syscall handler. Syscall handler is in an entry point of the processor that when your system boots, the kernel put the code there. And when you do syscall, syscall handler is launched, and he will try to find, searching by ID, what syscall it has to execute. So he will find this syscall on syscall table, find some address, and make a function call. We have talking about symbol here because symbol is the best way and the easiest way to find a syscall table address, base address. We have to find address we are going to change. To find address we are going to change, well, we can find that using symbols. There is lots of techniques that can find syscall table, but using symbols is more easier and better and stealthier. So we can use this function. If you grep this file, /proc/callsims file, you can grab address from syscalls, just doing cat /proc/callsims, grep a syscall, whatever you want, exit, what you want, and you will find the address of this function and syscall table because it's mapped. So you can find do it in a kernel module, just calling these functions. Callsims lookup name, passing a string with a name, and this function will find the address of the function, and you can put this address inside a pointer function to execute later, right? And you can use callsims on each symbols is another method to get address of a specific function, every function, but we are talking about here of syscalls, and to put in a pointer function pointer and try to execute it later. Okay.
Yeah.
It's all about.
Yeah. When you are inside the kernel and you want to modify something, there is a protection. Basically, the text section of kernel. Text section means the section that has the code. It usually it is protected from to be written from everywhere. So basically, to modify the kernel, you have to find a way to write protected regions, and usually it is this protection it is implemented inside the CPU, and this protection can be disabled by just removing one flag from one register, and this way. It's used widely, but it's not correct. It's not correct to use this way because write protection is the system mechanism that is used by the operating system to implement things like copy on write, COV. And if you disable for a while this copy protection, the kernel will behave unpredictably. So it's better to find other way how to modify the read-only memory of the kernel. And the other way is to make a temporary mapping of the same region, read-only region, but with different type. So basically, if you know how CPU works in this way that you have, for example, one page of memory, and this page may have two different virtual addresses inside the address space of kernel or user mode process, whatever. Yeah, and each of these addresses can be accessed in different way. One of these addresses can access through using one of these addresses. You can use refer to this memory as the read-only memory. But for example, if you have different mapping, and this mapping maps this memory as a write-enabled memory. So using different address, you can write to the read-only protected memory in easy way. So basically, this is the function, but I don't think that you are interested in functions now. This is how it can be implemented in C. Yeah, and this is, for example, if you want to modify syscall table, you can just disable protection, overwrite item inside the syscall table. Let's say my sysopen. My sysopen means my syscall open syscall implementation. Yeah, and you can unmap temporary memory, and after this you have the syscall table overwritten. Let's talk about hooking.
As I said, we will hook some syscalls, but we don't have to hook only syscalls. Hooking syscalls is nice to change the kernel behavior about userland stuff, but there's some ways to hook syscalls. I have told about that. We just will replace the pointer on syscall table. I told it before, and we have to hook the syscalls, but not only hook the syscalls, not hook only syscalls. We can hook another functions on kernel. Is the purpose of the next slide. Yeah, K-hook is a framework of hooking that search of symbols of the functions and try to hook the function in the product of the function, right? Can you explain that?
That's right. And you can find it on GitHub if you have interest in it. Yeah, and K-hook is a tiny framework that allows you to hook some function inside the kernel, whatever the function, and it implements some set of macros. You can use them like...
Yeah, it's very easy to use because you just declare the function that you are hooking, declare the function, the evil function below, and use this macros to just do the hook, do the fork of the flow.
Yeah, to change the flow. Yeah, and this is how the engine can be used. This engine can be used easily, but by adding 2 lines of include files and just modifying LD flags of the linker. Yeah, and so this is the example in C how this library can be used. And this example shows how to hook inode permission function. Inode permission function is the function inside the kernel, so it's
just a function that we are hooking and just doing that declaration up there. So you declare your function that will execute, and these macros just do that, and you can execute what you want and execute the original function.
Yeah, it's all hidden under the hood, under the framework hood. So you have not to know even how this framework works. Yeah, now we are going to tell you about some techniques that are commonly used in rootkits, like hiding of processes and hiding of files and directories. Yeah, so hiding of processes, it's a hiding of processes, and this is one of the most important features of rootkits. So every rootkit wants to have this feature, and it's not so complex to implement it, but you have to know how kernel works, how kernel manages the processes. Yeah, and to do process hiding, you have to do three things, basically. The first one is to be able to alter the process life cycle. You have to be able to attach or detach some information to processes while process starts or while it ends. And also, you need to filter some output of the kernel that kernel provides to user space. For example, there is a proc file system. Maybe someone of you knows about it. And through this file system, you can you can see all processes inside the system. You can see PIDs of processes and linked information to these processes. Yeah, and also, if you are hiding some processes, you also probably want to hide some CPU usage of this process, because this process can be hidden, but still can affect the CPU usage. Yeah, so about the life cycle. If you want to be able to hide process, you have to hook two functions. And the first function is copy credits function, and it's executed when the process is created. So in Linux kernel, creating of process, it is implemented through fork. So at each fork, the kernel creates a copy of process for you, and the copy credits function, it is executed. So it's a good place to hook, to be able to get control when the process starts. And the other function is exit credits function, and it is executed when the process dies. So it is the function when you can do some cleanup job like this. And this is the picture of process tree. When you want to hide some process, it means that you don't want to hide the exact process, but you want to hide, probably you want to hide all the subtrees of these processes. So let's say you want to hide this bash process. It means that you want to hide any children of this process also. I'll show you later how it works in demo.
Yeah, when you try to hide process, you have to hide threads and subprocess, and this thread of subprocess. So in kernel land, process and threads and another things is declared by a task struct. This task struct can be flagged. You can flag this task struct because when I hook a function that will deal with this task struct, you can know what process you are managing and what you will have to do with this process. Yeah, and there's a lot of functions that you can hook and to hide some process. And the main line is I have to flag process, threads, subprocess, and threads of subprocess. And try to hide all this shit. And just hooking some function and there is an example. If you hook this function, you can hide a process. And if you hook this syscall, getDent is a syscall, you can hide a process. So this syscall, you can hide that, but there's a lot of premise, lots of things you have to deal hooking getDent. So it's better hook that another function that is showed there, right there, and this function too, to get all process hiding and don't get caught about forensics tools.
Yeah, one of the greatest forensics tools that I met, it's unhide utility, and it's written maybe, I don't know, 5 years ago, and it is written, and it is not developed now, but still it can show many hidden things of operating system. And if you want to hide some process, you probably want to run this utility to see is it working or not. Yeah. About the CPU utilization. Yeah.
CPU utilization is a nice tool for hide, a nice technique to hide minors, because there's a lot of minors here, I know. Yeah, I know. So if you can run a process in your system stealthy, you have to hide a process, but you have to hide what these processes are doing too. And when you have a miner, this miner will consume your CPU, right? And you have to hide that. So if you just hook this function of kernel land, account process tick, you can hide a CPU usage. So just with the same technique, we are hide process. We flag this process, this text structs, all threads, all subprocess, all threads of subprocess, and hook this function. And when this function is called, my hook, our hook, will read what text struct is and try to return 0 and try to don't count time and hide CPU usage.
The next technique, it's the technique about hiding of files and directories. Also one of the most required features of Rootkit because it allows one to hide stuff on file system. Yeah, and basically it can be implemented using few approaches. Like the first approach is to filter out the access to files by their full paths. It means that when you want to open some file, you have to provide probably the full path to this file. And that is the one point from inside the kernel at which you are filtering something by full path name. And the other one is the set of so-called fildir functions. Those functions, they will be called when you're listing directories, and they are implemented inside the file system driver. And using these functions and hooking those functions, you can filter out the content of directories. Yeah, and for the first approach, for the first step, you have to hook those functions, 3 functions, and at any of these functions, you have a full path to the file, and you can filter out it's based on the file path comparison, or I don't know, whatever. Yeah, and for hiding your stuff from being listed, you have to hook other set of functions like fildir set of functions. Yeah. So yeah, we are close to demo.
Yeah. You know, I am a creator of Reptile. Is a rootkit that I have published that in this address of my GitHub, and I will demonstrate to you how it works, but not the old version. I will demonstrate the newest version, 2.0 version. So I will publish that in my GitHub soon, okay? Oh, sorry, we had lots of technical problem with the projector. I will try to show here in this shell because it's the only way. So keep talking. I will do some preparation here, and I will do this demo soon. There we go. So I will show a few parts of the code firstly. Here is my routine of start. So I'm just doing that hide function that hide this module from the ls module. So because when you load the module to the kernel, the module will appear. This is a driver, right? So you have to hide that. So that function will do that. I won't show you, but you will be able to see that in my GitHub. And you can, after that, I just make a hook on a net filter to get some magic packs. I will show this feature and get a backdoor and get a shell. And try to execute down there a script, initializing script. So I am hooking lots of functions. Yeah, you know. The communication of the rootkit with user LAN and kernel LAN, I changed because I was using the kills call. So now I am using input-output control. INET input-output control is a way to communicate user LAN and kernel LAN just with a socket. So I am communicating with this hooking input-output control INET, manipulating sockets. So locally, yeah. And this hook is a hook of the read. This hook just hides a file content, also a file content tampering. And this is very important for my rootkit because the persistent, I'm installing a driver doing some configuration in userland. And the file that does this configuration, there will be a content, a configuration, and we have to hide that. When the system is not booted, the module is not loaded, this file will be will be configured to load my module. And when my module load, my module hide this content of the file. But you can hide another contents, but I'm using to do that, to do the hiding of my persistence. So I'm hooking getDents to hide folders, process, and files, because all in Linux is files. So if you can hide files, you can hide process too. And this is an old method that a rootkit called Heron does. Later, a guy called Monad reimplemented this hook in the dimorphin rootkit, and I'm reimplemented too. But there is another ways, another better ways. It's just publish. It's just for publish. Yeah, and. So I won't show the code anymore because we are lost in time. We have lots of things to show. I will show this rootkit running, okay? Because we are getting some problems of connection here. To install a rootkit is just run this command. This will run a script to compile, configure, compile, and install. Oh. Yeah. I'm gonna do that with default configuration. Compiled and installed. Now my script will create a folder called reptile in the root. If you, sorry. There's not reptile there, but if you get inside, there's a folder right there. And if you, there's nothing, but there is something. So because there's a lot of binaries here hidden that my rootkit will use and will try to do something, right? So I'm gonna show you the shell is the best part. To compile the client, you have to just do this command, and it's compiled. Just run the client. And we got a shell like a Metasploit, okay? just like a message plot, you can configuration what this client will do. This client actually will send a magic packet that can be TCP, UDP, or ECMP magic packet, and my rootkit will catch that and return a shell. So I will show you. SRC host is a source host of the packet that we'll be sending, so you can spoof that. Our host is the target. I will use ICMP protocol to send this packet. And as I'm using ICMP, I don't need to set up ports, right? I will set up, just run. Oh, shit. Sorry. I will do it locally because we have a problem of connection. And there we go, we got a shell. Just type my password. And we got a reptile shell. This reptile shell is like a interpreter. So if you type help, you will see the commands you can do. You can upload and download files. You can got a TTY shell, and you can set up a delay that this shell is gonna connecting back in each time you want. So we got a shell, okay, in a reptile shell with a TTY, and you can, if you can see, all process of the shell is hidden, all connections hidden. I will see you. Nothing. Nothing. And I used a 444 connection. You will see the connection of the reverse shell won't see, but the connection of the client will see, because this is the client is in the attacker machine, and I am using it locally, so you will see just the connection of the local of the client, but the connection of the reverse shell you won't see. Yeah, you know, you have to see two connections here. One of connections that get out, and another that is receiving. So the connection of reverse shell is hidden, but the connection of the client is showing. So nothing. My mod is hidden too. The kernel mode is hidden. And nothing. All hidden. We got a shell. We send a package. We got a TTY shell, and all stuff is hidden. And there's another features that you can got with this reptile, but we have a limitation of time, so I will pass the talk to Ilya to keep to do the next part of our talk. Okay.
Yeah. Okay. Let me continue about some advanced techniques, so-called advanced techniques, because we are in time already. So you know what that the kernel has audit subsystem, and audit subsystem it allows to monitor some process activity, blah blah blah. So basically, audit subsystem can be bypassed easily just by design. When you are inside the kernel mode, you can just hide you can just hook the function audit alloc function, and this function it is called on each process start. So basically, this function allocates audit context. And in this function, you can just remove one flag from so-called thread information flags. So you can just remove this flag, and the kernel will not audit those processes. So it's easier. Yeah, this is the code, but it is not so interesting. Yeah, the other technique is to filter out kernel log. So kernel log is something that you can observe using dmest command, and this is the buffer inside the kernel in which kernel prints some messages by using printk or like this. So basically, when it can be useful in situations when you want to hide some activity of kernel model or something other from being observed by utilities like dmest and syslog. Yeah, and when you are loading the kernel model without the signature, there will be a message. Always there will be a message inside the kernel log that model verification failed because of missing signature. Yeah, and by using this technique, you can just filter out those messages. And there are two ways to get information from the kernel log. The first one is the syslog syscall, and other one is proc-kmcg. The first one, syslog, it's quite old mechanism, but the other one is quite new. And finally, inside the kernel, there is just two functions that you have to hook to be able to filter out those messages. Those messages, they have different types of formats, but basically, this is the row null terminated /n terminated, new line terminated based messages. So the algorithm of filtering out this message from kernel log is to hook those functions, do syslog function and def kmcg read function. Let them do their job by putting information from the kernel to the user space. And after this operation inside the hook, you have to reread this information from user space, filter it out inside the kernel space, and put it back. Maybe probably altering the final length. So the length will be altered if you're trying to filter out some messages. And other technique I want to tell you about, is the so-called Matryoshka technique. Do you know what is this? This doll, right? You know Matryoshka, yeah. And this is something that allows you to break the signature, because when you're writing some kind of special software, probably you don't want to have a static signature. So this technique basically based on two modules. You are writing your payload inside the first module, and you are using the second module loader just to load the first module from inside the kernel. And the original model, it's stored inside the loader in encrypted form. So it's easy. And it allows you to get the following result. Let's say I have two modules, and the first module I call it parasite, and the second one it's parasite loader. It's yeah. And inside the first module, I have the static string like H2HC 2018 conference, blah blah, and I can grab this signature just using grep. And when I'm trying to grab the same structure from the loader, I cannot see this structure. But after this loader being loaded inside the kernel, you will see that first of all, parasite loader starts, and after this, the embedded model starts. So this is a basic technique, yeah, but it allows you to not to have static signature. And also there is one technique to obfuscate C strings from inside the C code. So basically, the problem of C strings is that the binary can be easily fingerprinted by using different kind of C strings embedded inside the binary. And you can use this simple technique. It works only for GCC compiler. But basically what it does, just changes the static string in form of quota hello world. It changes it to allocating some on-stack storage and fill this storage with some values. And basically this is the hello world, but in hex form. Now I can show some demo if we have some time. Okay? Okay. So I want to show you two things. The first thing, do you know what's LKRG? This is the Linux kernel runtime guard project. This project is intended to help to detect malware from inside the kernel. So basically it implements integrity checking and stuff like this. So to bypass this, I will show you how to bypass this checker. So this is, I'm trying to remember what to load first. Okay. I'm loading now, I'm loading the protection model inside the kernel, and you can see that this model is loaded, and you can see you can see that this model where is it? Where's the mouse? Oh, no. Yeah. You can see that this model, it's printed some stuff on the kernel log that, okay, the system is clean. Now I want to insert the model that is hooking some function. So yeah, this function, the function hooked is the load elf binary function, and this function is called on any binary started. For example, I can start sleep here, and you can see that hook is called. And you can see also that Linux kernel runtime guard, it shows us that the system being compromised like this. So now I show you how I can bypass this by loading other model which embeds the bypassing mechanism. Yeah, no, I'm starting again to load LKRG. It is loaded, and now I'm loading the other module. Yeah, and we can see now that LKRG started. But we can see that it prints no messages to the system log. So we can call many times this binary. We can see that this function is hooked, but kernel protection module it's not printing anything. So it is bypassed. It can be done because you cannot build a good protection on the same level you are attacking in. Yeah, and now I'll show you how to use process hiding, how it works. So basically, I have rootkit installed now, and it is now inside loaded inside the system, and I have the controlling script that allows me to spawn something with in hidden way. Let's say it will be bash -e. So now I'm inside the other bash, and I can run sleep 100. And from the other terminal, I can do piece3 to see sleep, for example. And you see that there is no sleep process, but it is run here, and it is run in hidden mode. So rootkit hides this sleep process because it was started with some flag. Yeah, and I can also show you how the CPU utilization can be hidden also. This is the Yeah, this is kind of mining, but so what this script does, it just takes zero memory and puts it to null device. Yeah, but it produced some load, but you cannot see this load, CPU load on this htop, and you also cannot see this in the list of processes. It is hidden. Yeah, that's it. So guys, thank you for watching us. Any questions? Slides.